Hi, my name is Ali Spiegel, and I'm going to be talking about the 2019 AP FRQ number 3, parts A and C. So as you can see, we're given a graph, so it is a graph problem, and some tips are that it's common to get graphs that are geometric because you can find the area under the graph using geometry, and if you're not given an equation, you should be able to solve with the graph, and if you're given f prime, you find the slope at a point. So for part A, we're given the integral 5 to negative 6 is equal to 7, and we're finding the integral of negative 2 to negative 6. So what I'm first going to start by doing is finding the integral of negative 2 to 5. So from what I'm going to be doing is finding the area using geometry of all these shapes and adding them up to find the integral. So what I'm going to be doing for most of these, because you can see they're all triangles, I'm going to be doing base times height divided by 2. So as you can see, I did that for most of them. And then for the last, this subinterval, 5 to 2, it's an irregular shape. So what I did was found the area of this square, which is a 3 by 3 square, and I subtracted this quarter of a circle. So I did the area of the square, which is 3 squared, minus 1/4 pi r squared. And then I simplified, and I got that the integral is 11 minus 9 pi over 4. And we're still missing the integral of negative 2 to negative 6, which we were originally solving for, but now we have the integral of 5 to negative 2, and we're given 5 to negative 6, so we can just plug in the values we know and found, and then move everything onto one side and simplify, and we get 9 pi over 4 minus 4 as the answer. For part C, we're given g of x, and we're finding the maximum value of g on the interval. So what I did was took the derivative of g of x and got g prime of x is equal to f of x, which is also equal to 0, because we're finding the maximum, which means that the maximum point, the slope has to be 0. So the zeros on the graph are negative 1, 1/2, and 5. And I also included negative 2 because it was in the interval given. And I'm just finding when the points are positive and negative, and I'm just looking at the graph and seeing when they're above the x-axis and below the x-axis. And then taking these zeros and just plugging them in to the integral that was given. And then, so from negative 2 to negative 2, the integral is just 0. And I'm just using geometry to find the area again. So from negative 1 to negative 2, I'm just finding the area of these triangles and adding them together, and I got 1/2. And then from 0.5 to negative 2, I did the same thing. And then from 5 to negative 2, we found that in part A, which was 9 pi over 4 minus 4. And then when we compare these four values, we get that g of 5 is the largest value, so therefore it is also the maximum.